Well, welcome everyone. Thank you for joining the Career Paths in Electronics discussion this morning or afternoon, depending on where you are based. We are thankful to have a lot of students and teachers, university and college professors in attendance. It's been a wonderful opportunity for us to share journeys of fantastic professionals in the industry with you all, because we know that everybody's journey into the industry is unique and that you can enter from high school, associate degree, or full 4-year engineering college degree behind your name. So we just want to share as much information we can to help everyone consider pursuing a career in the electronics manufacturing industry. I'm Charlene, and it's exciting for us to bring this to you as the Senior Director of the IPC Education Foundation. I have with us our President and CEO from IPC, Dr. John Mitchell. I want to just read something about our wonderful leader in charge. John leads the organization's global operations and staff. Working with the IPC Board of Directors, he is responsible for assisting in the development and implementation of the board's strategic vision and aspirational goals. He joined IPC as president, as CEO in April 2012, and has been instrumental in launching solutions to help IPC members achieve financial success and competitive excellence. And therefore, it's wonderful for us to have him here today to provide not only an overview of IPC and the electronics industry at large, but also to moderate the panel. We have a fantastic group of panelists lined up, and each one will have the opportunity to introduce themselves later on. On the call, I also have staff members, Erin Burney, our program manager, who leads up our exciting chapters, student chapters across the university and community technical colleges within the United States and hopefully internationally soon. And Gentry Manning, who's supporting us from a marketing standpoint. So without any more elaboration, I'm going to give it over to John to talk about the industry.
Okay, so let me share just a brief industry overview. It won't be terribly in depth because we do want to get on to the questions and answers in the engagement, but I don't want to also gloss over it. So let me tell you just a little bit about IPC to start with. IPC is a trade association for the electronics industry. And what that means is that our role with the individuals across the globe is to work with the electronics industry, those who are actually building electronics, as well as designing them, et cetera. And we are a nonprofit. We work with thousands of companies all over the world to get them to come together to help us to build standards, to develop education material, training, certification. We work with governments across the world. We have offices in Brussels as well as Washington, D.C. and Beijing. And really our role is to help the industry build electronics better. That's our whole focus here, and we do that in whatever way that they need. We spend a good amount of our time listening to those companies tell us where their challenges are, and helping them then where we see a synergy of those challenges is where you'll see us establish programs to help resolve some of those challenges. I think we're going to start with just a little intro video. Charlene, you want to play that? It's about 1.5 minutes.
Absolutely.
It'll work for you. It is going to be streaming and then streaming to you, so we'll see how it goes.
You know how a light bulb works, right? Electricity flows through power lines to your location, where it passes through a light bulb and makes it glow. But what about more sophisticated products that contain electronics, like smartphones, cars, or pacemakers? How do they work? The basic science is the same. All these devices take in electricity and then steer it through a specially designed maze of circuits and components, and voila, you're chatting with distant friends in real time or getting to your mom's house safely. The way most machines are designed, you'll never see the electronics inside, nor will you know where they came from or how they work together. But make no mistake, in today's world, our lives and our communities depend on electronics. Whether they are tools for work or systems to protect our health and safety, electronics make them possible. At IPC, we coordinate with industry, academia, and government to make sure that electronics will work reliably and safely, so that you can keep doing what you need to do. We support thousands of industry members worldwide with standards development, workforce training, research, and public policy advocacy. 80% are small and medium-sized businesses. With so much at stake, isn't it time you learned more about the crucial industry that's at the heart of the modern world? Visit IPC.org and follow us on social media. IPC, build electronics better.
Thanks, Charlene. I hope that was, I hope you were able to hear that. If not, you can always find it on the internet and pull it up at any time. You want to switch it to presentation mode, Charlene? There, I think we're still in. So just like, I mentioned, we work with a number of companies, many of the brands that you'll recognize. Here's a few of them just thrown together on the slide here. But we also work with the brands that you don't know about, the ones that work behind the scenes. While you may have Apple design a phone, they don't necessarily do as much of the actual manufacturing of it. They have suppliers that build that. If you can go to the next slide. And that building of electronics consists of many different parts. There's the printed circuit board fabrication. That's that, often it's the green board that actually all of the chips go on. You've got the actual components. You have cables that connect various pieces, and those cables can be of various shapes and sizes. Plastic and metal components. There's 3D printing that can take place, epoxy and adhesives, various process materials. And so all of that goes into the electronics manufacturing. You have the OEM really doing a lot of the designing. Then you have what's either an EMS or an ODM. An EMS is an electronics manufacturing services, and they tend to take the materials and put them all on the board. And then you have an original design manufacturer, an ODM, that they really manufacture a module or a subsystem that then gets utilized in the larger whole of the system. And then, of course, you have software, firmware, and apps, and then various certifications and regulatory and standards. And all of that comes together through a wonderful process to deliver your finished product, whether it happens to be, the screen that you're watching this video on, or whether it's, your phone that you're talking on, or just about every single industry uses electronics to deliver whatever service they're doing. So it's a critical industry and very exciting. We're using a lot of the latest technologies. I mean, they're integrating AI, robotics. We mentioned 3D printing already. Just a lot of the latest and greatest things that you hear about are happening in factories all around the world every day. And so that's just a brief overview of what the industry is and what it consists of. I'm sure there may be a lot of different questions about that, but let me, I think, move on to the panel if we can, and we'll start. Well, I'll start with a few questions after each of the panelists introduce themselves. And then after that, we'll get into, we'll also allow you guys to answer some questions. You can either do that via the chat, and we'll try to keep track of those questions, or there's actually, because it's a webinar, there's a question and answer box there. If you could type in your questions there as well, that'll help us keep track of them. And but let's get kicked off here. So first, as was mentioned, I'm John Mitchell. I'm the president and CEO of IPC. And let's go to our panelists. First, Melby, why don't you introduce yourself? Tell us, in just a couple, 3 minutes, a little bit about where you're from, where you went to school, what you do now, and how did you end up here?
Can everyone hear me now?
We can hear you.
Perfect. So I'm Melby Muckom. I've been working for about 5 years now. I have my bachelor's in material science and engineering, and currently I'm supporting manufacturing at General Dynamics, specifically with pick and place equipment. And I guess to answer your question on how I got here, I fulfilled, I guess, like a lot of different roles that ultimately led me here. So I started out as a process engineer, doing a lot of continuous improvement, and then it just morphed into this role now.
Okay, and we'll come back to that a little bit because I think that you may hear a theme, those of you who are listening, as part of the career path. But Tayler, why don't you go next? Share a little bit about yourself.
Sure. Hi, everybody. I'm really excited to share a little bit my story and listen to all of the other great panelists here. I started off as a head of maintenance in a local electronics manufacturer and cleaning toilets, and couldn't stay away from all the cool stuff they were making. And then I ended up going to RIT, Rochester Institute of Technology, and also took STEM classes. Of course, those were a huge help leading me to engineering in high school. And then I did electromechanical engineering undergrad, and I started working on a project that was actually it was like a grant program with IPC and Lockheed Martin. And at RIT, we have an electronics assembly lab, so we really can build the full board to assembly with the whole process. And that was where I spent most of my late nights in college, and got wrapped into the emerging engineering program and got a great mentor. And currently I'm a engineer team member at Digital Instruments in Buffalo, a small electronics manufacturer, mostly temperature monitors. And that's where I'm headed to stay, and looking to deploy a few of the IoT devices out into the world, and making sure we're building those and designing them to the high standards.
Excellent. Thanks, Tayler. All right, Jarrod, your turn.
Yeah, thanks. Can you guys hear me okay?
We can.
Perfect. Well, yeah, my name is Jarrod Webb. I graduated from UT in Texas, obviously, and didn't really know what I wanted to go to school for. Knew I wanted to do something in engineering, but wasn't really sure which field to kind of pursue. And I decided to go mechanical engineering because I felt it was the most broad. Didn't have to really pick yet. And come to find out, I worked at a couple CNC shops, local mom and pop type shops here across East Texas, and worked for Parker Hannifin rubber manufacturing throughout college. And a headhunter came and found me from Lockheed Martin and asked if I wanted to move to Lufkin, Texas. I'm from Houston, so I'm already in a small city, and thought I wasn't really too excited about Lufkin, Texas. A lot of people don't know where that is, and decided, you know what, let's give it a try and hear them out. Is one of the best shops I've ever been to. I mean, clean. It's just, I mean, if you guys have been to a Lockheed Martin site, I didn't know that was the status quo. But it was absolutely amazing. So accepted the job as a associate engineer, just fresh out of college. And within the first year and a half, they promoted me over an entire area, overseeing the production processes of missiles and fire control systems. So circuit card assemblies, wire harnesses, boxes, stuff like that. Then within about a year later, put me to a senior engineer over the automated process group. So I oversaw implementation of all automation across our site. And then just February this year, moved into a new role, the same facility as a robotics staff engineer. So now I oversee the sites, regardless of the department, the sites innovation, IFF integration, CFX capabilities, 2581 capabilities, obviously DPMX. And when I first started at Lockheed, I had a great mentor who, Josh Goolsby, some of you guys may know him, who lumped me into IPC. I've been on standards committees before for when I worked for Tank Connection, which is dry bulk, liquid bulk storage tanks. So I was interested in standard committees. So when I got involved with IPC, it just kind of grew from there. And the connections I made with IPC are kind of what slingshotted me into my growth path that has been pretty uphill. So I'm kind of excited for it to slow down a little bit. So you can promote fast, but if you don't have the experiences, it gets detrimental. And so I'm looking to now slow down a little bit, develop that expertise, and kind of start mentoring folks behind me and getting them to where I am and pass me up eventually. So that's kind of it in a nutshell.
Very good. Thanks, Jarrod. And Sarah, bring us home.
Hi, everyone. I'm Sarah Czaplewski. I am a printed circuit board qualification and reliability engineer at IBM, located in Rochester, Minnesota. So currently in my role, I work with our printed circuit board suppliers to ensure that they're meeting our quality standards and generally are requirements that we need. I also work with them when we have any kind of tests, manufacturing, or field failures to help address those and then implement corrective actions. So I have a bachelor's and master's degree from the University of Wisconsin-Madison. It's in biomedical engineering, actually, with an emphasis on materials. So when I first started at IBM 7 years ago, I was in the materials and process engineering lab doing a lot of hands-on materials testing and characterization and failure analysis of all different hardware that goes into our servers, right? So everything from the wheels on the racks to plastic latches to solder joints and thermal interface materials. And then from there, I kind of morphed into just taking over printed circuit boards, so kind of leading the quality assurance aspects of that for IBM.
Excellent. And a special thank you to Sarah, who's jumped in at the last minute here. We had a panelist who had a conflict and they were unable to join us. So thank you very much for being willing on short notice to join us. Well, thank you to all the panelists, but especially for the impromptu. Yeah, I'll do it. Thank you. All right. So let me start off with a couple of questions by me, and then we'll look to see what the audience has. So let's start with it's not a very far rewind for most of you. Think about if you were a high school or college student interested in exploring a career in electronics or engineering or manufacturing or whatever, in your current field of expertise as well. How would you recommend getting started? And just jump in, just start talking. There's only 4 of you. We're not going to talk over each other too badly.
I can start. So I think job shadowing, or at least interviewing people in the industry, is really important to kind of understand what they do on a day-to-day basis, right? It's one thing to kind of read about it online, but I think it's really important to understand what people do daily so that you can decide if that matches your interests and find something that you really enjoy doing. So that's a good place to start, in my opinion.
And I think Sarah's dead on the money. If you know somebody who is already in the field, reach out to them and kind of walk a day in their life in their shoes, and see if that's something you're still interested in. If you don't know somebody, I've found the most success in people who are interested in it, in kind of a STEM field, of just joining your high school robotics team. It's something so simple that a lot of high schools are now having, but that on a resume speaks volumes to at least me and a lot of other folks in the industry when you have that background of working with those different connections, even if it's just something simple like an Arduino, it's just, you've already had that background, you've already had the hands-on experience, just something that adds to your resume that can boost you above somebody else. So I would say start small there, and then the job shadowing is a great thing to step up to if you have that opportunity.
Yeah, and that was a good point Jarrod made about Arduinos or any of those Raspberry Pis starter kits. You'll be surprised maybe even your family members are interested in it, but they just maybe are too busy. And if you're just starting off, get them involved and say, yeah, you want to maybe make a remote blind opener, or have your own alarm clock or things like that. And I certainly was surprised that my uncles were interested in tinkering, and neighbors as well. And that sort of was another thing to put on the resume, is a project that you did. And those are big things that you can talk about in job interviews, is just projects and how you handle diversity. And if you didn't know anything when you started, but then you can show off that you actually figured it out, or you were motivated to find out more.
Let me just echo a little bit on what you're saying there, Tayler, on the job interview front. So when I was a director at Bose, I interviewed over 2,000 engineering candidates over about a 4-year period. We were setting up a brand new division. It was crazy. But anyway, you're right. The stories are what people remember. It's not just about, did I do the classwork? Did I do the grades, et cetera? They want to know, we want to hear the stories that you have to share. Hey, I built my own electric guitar, or I tried to do this and I failed, and this is why. And you just get really engaged that way and become memorable, frankly, because there's a lot of people out there competing for them. Melby, anything to add?
I'd say, so times have changed a lot, and I know that it used to be, I guess, more acceptable to get internships in college, but now there are plenty of companies, I think on the top of my head, maybe AT&T and Texas Instruments, that actually offer internships to high school students. So I think that's a good avenue. Just get your foot in somewhere, see whether you like that line of work, and then that'll help you get a little bit more situated for any future opportunities you want to pursue.
Yeah, the internship is like a step up from the shadowing, as opposed to just doing it for one day, which is great. You can play with it for maybe a summer and say, oh yeah, I really like this. Or I saw this job that was happening across the aisle or in the room next door. That's really what I want to do. You know, you get a sense of really what's happening. Thank you for sharing. That's awesome. So I'm going to divert a little bit so you guys stay on your toes here. I'm just making up questions now. I'll come back to some of the ones on the list, but if there's someone in your past, because I think it relates to what we just talked about, who was a hero or a great exemplar for you, or somebody that you said, wow, I really want to pattern myself after them. Who was that? And how did they inspire you to take the path? And you may have followed it or, you know, diverted from it eventually, but what kind of person did you look for an example to kind of inspire you into the electronics arena?
I can jump in.
Okay, go ahead. Thanks, Tayler.
Somebody that I really thought is just the quintessential ideal, you know, inventor, engineer is Dean Kamen. And he has always made engineering look so accessible and so practical for anybody could be thinking of some sort of solution. And there's a way, if you really put in the work and figure out the physics and everything behind everything and the electronics, you can come up with real life solutions. And, you know, perfect example, you know, not only was he maybe labeled the Segway guy, but, you know, he was doing glucose monitoring, and he was doing new ways to partner with Coca-Cola to stop, you know, world, you know, polluted water solutions. And he's, you know, leads the way in that. And I highly recommend anybody to do a little bio on Dean Kamen. He's, I have a little picture of him on my my desk, but that's just one person. That's like a rock star, though. And,
Tayler, were you at our Apex event when Dean Kamen spoke to us? Did you get a chance to meet him or not?
No, I wasn't at that one. I do have my lanyard though from back in the 2016.
Yeah, Dean was a great speaker for us. All right, anyone else, heroes or mentors, role models?
Yeah, so during my first internship, was actually at Procter & Gamble. So it wasn't in the electronics industry, but it was just my my mentor during that internship. She just thought so much outside of the box. And I think that really showed me kind of how you can expand into new areas and not be afraid if you don't have the background, right? That you can contribute and be, you know, a strong leader in those kind of fields and still contribute to things. So it's just like personal mentorship that I would say has kind of been my guiding light into engineering.
Awesome. That sounds like kind of what Jarrod's having to live a little bit and getting promoted and kind of figure it out from the seat of his pants, but good job.
Kind of a good luck deal is what I've fallen into. And similar to what Sarah's saying, I don't have any probably big instrumental key players that, you know, are worldwide success, but just locally and maybe just within Lockheed is, I mean, a lot of you guys know Don Dupriest or Ben Gumpert or Bill Fox or some of these guys, even within the committees, even if they don't work for Lockheed Martin, there's a lot of folks with Honeywell Aerospace that have been huge for me and implement, you know, and just kind of reaching out. I would reach out to them if I got stuck on something or just didn't understand something in the standards, but having that open line of communication that it was first how they responded to me, how it was open. It wasn't just, oh, you work for a different company, or, oh, we don't really know you. I mean, they were welcome. And the emerging engineer program really probably bridged that gap. But even outside of that, since I graduated, that bridge is still there, and we use it all the time, and back and forth. And now I'm finally feeling that I'm to the point where I can actually contribute back. Right. I think they've been kind of carrying me for a while. So, but yeah, yep.
Yeah, to piggyback on that, I can totally relate, because when you're doing research and you start reading all these technical papers, and I mean, Sarah, you know the background, I'm sure all the other panelists know too, is you start seeing familiar names on these papers for solder reliability. And next thing you know, you're at an IPC event and you're actually meeting these people. And I think I was a little put back. I'm like, these are kind of rock stars. Like,
Yeah.
and you know, everybody wants to talk to these group like Dave Hillman and
Yep.
you know, and you know, my professor at RIT, Dr. Ram Kumar, he does training. He's been doing trainings and you know, seeing people progress from you know college all the way up to senior executives, and he knows so many people. So it's cool to kind of see how that can bridge your relationships, and people are so friendly too. So
Awesome. Very good. Any other thoughts on the heroes or our role model question? All right, let me move back to, oh, go ahead, Melby, sorry.
Yeah, I just wanted to quickly offer, it's not quite in line with the question, but I did want to share this, I guess. So the person that came to mind for me is my mom, because she went back to get her bachelor's at 52 and her master's at 56. So kind of on a separate tangent, I guess, wanted to share that specifically because I think it's kind of difficult to know which line of work you want to go into as a high schooler. So it's important to understand that while the majority of people know exactly what they want to go to college for, it's okay to take some time and figure out, hey, maybe let me try out 3 or 4 things and then eventually go into the line of work that I want to go into, because it's never too late to honestly go back to school.
Yeah, that's a great point. And frankly, the more diverse background in several different things that you've done, it helps you think more creatively and bringing different solutions. And that's what we're all trying to do, is be innovative and try to find different solutions. So I would echo that point, Melby, that don't stress it. You know, I've how many years have I been out in the industry now? Too long. But I feel like every 2 to 4 years, I was doing something different. And so, you know, you go focus on this, and whether it's a different project or a different role or what have you, you're constantly changing yourself. And so trying to assume that, you know, hey, I'm in my teens or my 20s and I'm going to know what I want to do for the rest of my life, not often realistic, because the world's changing around you as well. So don't stress it. Find something you're going to enjoy now and go after that. And if it changes, it changes. It'll be all right. And it'll just give you much more experience. Super. All right. So talk a little bit, if you would, share what kind of some of the interesting or emerging technologies that you work with that are exciting to you.
So I've had the chance to contribute a little bit to IBM's quantum computing efforts.
Oh, cool.
So yeah, you could talk a whole separate webinar to explain what quantum computing is, because it's really complicated, but basically it's just, instead of classical computers, they can do a lot more computations much faster. So for like simulations and things like that, it's really advantageous. And so you have to have very, very cold temperatures, like 4 Kelvin, to make it work. So there's challenges in obviously making hardware that can withstand that. And then that super cold area talks to electronics in the room temperature. So you have to be able to transition between room temperature and these extreme cold. So there's a lot of engineering challenges associated with that.
That is so cool. We're going to have to talk later. All right. Other thoughts? Other technologies you guys are working with?
I had a chance to work with silicon photonics. I think somebody asked about what do they think the new future is all about. And, you know, I certainly saw the advances of integrating, you know, silicon photonics. If you're not familiar, it's basically our fiber optic networks that we all run on use light instead of the traditional copper wires, and the speeds are like comparing a 8-lane highway. Only right now we have off ramps that are only 2 lanes or 4 lanes. Well, now if you use silicon photonics to get to our devices and our routers, everything like that, it'll be on and off 8 lanes and much faster. And you know, that's really cool on the leading edge of the technology world. And I certainly think that, you know, if you're looking to get out into the new fields like that, those are really cool to look at.
That's awesome. Gotta love that. Jarrod, Melby?
So a couple of the things that I'm really excited about. more personally than out, within Lockheed or without a Lockheed, but just on a personal level is the whole digital product model. I know IPC's been behind that, but that is something that's so cool to me, is to be able to get, I call it dumb data, and that's really what it is. When you get a PDF document that, you really just have to read it and your machines can't touch it. So it's been automate for so long, but at some point we have to innovate. And so we have all these really smart machines, but they can't talk to each other. And so using this digital product model, so you have one source of truth that you can get from your design team and just plug in and have all your programs made, and then loop that back with what's going on with CFX and the 2591 standards. That kind of stuff is just super intriguing to me. And that's kind of why I jumped into that OEM chair position on CFX, was because I think that's where the industry is going, and it's good to see IPC behind that. But outside of that, I'm really interested in the robotic arms. I know that's been around for a while. I know everyone's probably seen one at this point, and a lot of sites are now starting to get them. But it's just really cool when you can start using those arms to do, anything that you can think of. But I'm really interested in the camera systems that are now available, some of the 3D vision systems, where your operators aren't really having to scan or manually type anything in. It's just having a 3D camera system. It knows what's in front of it, and it automatically loads the program and does the task. So stuff like that just really hits home for me and gets me excited on what's next.
Excellent. Melby.
Same as what Jarrod mentioned. The world is becoming very automated now. So for me, it's really interesting to see how all these pick and place systems are so automated to the point where you literally just have to watch until boards are processed, and you can get out maybe at the rate that we're building right now, we're getting up to 3,000, 4,000 boards out every week. So it's just really interesting to see how something that's, not living can do such efficient work with such low maintenance and not much of a hands-on approach.
All right, so let's cover some of the basics here, because I see we've got several questions here. Let me go off. I'll do one that's going to kind of wrap three questions into one, or two questions into one anyway. Let's share with the group. First, what do you think you need to do to stand out? I know we heard Tayler talk a little bit about sharing stories, when you interview, but what do you need to stand out? And then what sorts of degrees or education or training would you recommend for up and coming students?
So I can take that one. I think the first thing I would focus on is your studies. If that's the first thing you're looking at, is make sure you keep grades. And I was never the most book smart person. I'm a B+ student at best. And so I had to study very, very hard to get through some of these courses. But outside of that, it's to me, I've found more success in networking and finding people there's always someone stronger, faster, better, smarter, but working together, you bring something to the table, but there's always someone better at something. And so it's kind of building that network of friends in a group that you can attack a problem as a team, being able to demonstrate that at some level, whether it be something you did in school or high school or something you're doing for fun, even if it's a team sport, right? It's something like that, and bringing those answers to interviews and feeling comfortable in interview and not nervous by the awkward silence that are in some interviews. As soon as you get comfortable with that, I think it goes a long way.
Cool. Very good. Other thoughts? How to separate yourself and what degrees, et cetera, might be required? Go ahead.
I think having a good network and being able to market yourself is really important. So from personal experience, I would start with having informational interviews with people in the industry that you want to be in, or people who have the jobs that you want to be in eventually, and just talk through any questions that you have, understand truly what the role calls for, and then really understanding how maybe if you had a summer job and it's not quite in line with this job that you want or this internship that you want, figure out from having these informational interviews how you can tailor what you've been doing at your current job to market yourself to be a good fit for this new job that you're looking for.
Yeah, that's great. That's great. Thank you.
Yeah, and we've just been interviewing some candidates recently, and I think something that really helps people stand out as having good communication skills. So, right, you can have the highest GPA and great work experience, but if you can't convey, your experiences and explain why you would be a good candidate, that's definitely a problem, right? So I think good verbal and written communication skills definitely go a long way, and sometimes that's not emphasized enough in engineering curriculums.
Yeah, let me touch on that a little bit. So as I mentioned, I did an awful lot of interviewing when I was at Bose. And a lot of those candidates were MIT grads, really smart people, and it was interesting. Even if they had a 4.0, if they didn't have any diversity, we weren't as interested. It was like, yeah, you're really smart. That's great. But we want people who are broad too and have other interests or have done other things. And then as on the communication front, it was so great. Yeah, you can tell a story, but what we love to see on our engineering interviews, if they went to the whiteboard, we'd ask them a question, have them do something, and just about every office we ever had a whiteboard in it. If they're like, well, you start to describe and say, actually, are you okay if I draw this up here? And then they start drawing pictures. We're like, oh, we love that. That's awesome, because it helps us visualize and communicate that stuff. All right. Sorry, Jarrod, I interrupted you. Go ahead.
No, that's exactly what I was gonna mention. I mean, that's Sarah's kind of hitting it there. That communication factor. I mean, it's almost if an interview was weighted, that communication factor, to me, I care a lot more about that than I do what degree you came out with. As long as it's in the correct field and it's a technical degree, I mean, to me, that just means you can learn things. But if you can't communicate things, then we're going to have bigger issues, because half the stuff you're learning in college, it's great. It's going to get you in the right boat and it's going to get your mind working in this way. But at least for me, everything I'm doing today, I learned at work. I learned in the industry. I mean, I was really good at Cal 3, but I haven't done a triple integral since I graduated, right? Because I don't need to. So get the degree, get the paper, do the paperwork, get it done, but be able to learn and then be able to, communicate that to somebody else. Because once you figure it out, you're going to have to teach someone else. Because if you can't teach someone else, you've pigeonholed yourself. Right. And as soon as you can teach your replacement and train your replacement, you're going to grow on to, you're going to move on to better and bigger things. And so that's the biggest thing. I'm glad, Sarah, you mentioned communication, because you're right. It's completely underrated, but I think more attention's getting drawn to it.
Yeah. And don't be afraid. Oh, sorry. Go ahead, Tayler.
No, I was just going to say, just to echo that, was, leading it back full circle is, people want to know, I think we have a question or two about, what are the best opportunities? The opportunities are when you actually start communicating to others of what you're interested in. And when you stick your neck out to maybe talk to somebody either online or, at a local manufacturer and ask for a tour, you're presenting yourself, and that is already a huge step. Because you're communicating to the world basically that you're interested. You have the motivation, and whether it's changes tomorrow or whatever, as long as you start having those conversations, that's all in your arsenal to then say, maybe I'll circle back to design work. Didn't really like that, but I'll go do manufacturing, things like that.
Yeah. So just a couple of thoughts, and we'll go to the questions. So first on Jarrod, I think you mentioned that, well, yeah, I was looking for an engineering degree, but it doesn't even have to necessarily be just an engineering degree. It could be mechanical, it could be whatever. But when I was at Alpine and we were building the original GPS systems launched here in the country, our best people were physicists. They weren't, we hired all kinds of people with all kinds of backgrounds. They didn't have to be one specific kind of engineer. It's really about, like you were saying, Jarrod, can you solve problems? Can you bring to bear different experiences on the challenges that you're going to face? Melby also mentioned networking. Let me just share an example. I hope I'm not letting out. So our current, one of our board members at IPC is a student, Paige Feet. And Paige received a job offer, and then due to part shortages, she found out that job offer was going to go away. And she found out just before she came to our board meeting. And in our board, we have about 17 different CEOs of different companies. I think she got 4 different job offers that night from the CEOs. So the networking piece is huge.
That's awesome.
So I don't know if she's going to take any of them, but she just had that, she was really let down. It's like, oh my gosh, I'm not going to get this job. But suddenly it was like, I have all kinds of opportunities. So knowing people and getting engaged in industry groups and with your peers and even outside your peers, it will also help on that networking piece. All right, let's go to some of these questions. I'm going to try to take them from the top here. Landry Smith asks, as a high school or college student, what are the best opportunities that I can take hold of to ensure success in the engineering field?
So I think we mentioned a little of those, but just to kind of, I guess, mention them quickly on the ones I'm thinking of is any STEM programs you can get involved in high school or college. Any robotics, our local high schools all have robotics. I wish they had it when I was in high school there. So if your high school or college has a robotics club, I've found huge success in that, and not just from me, but from people we interview. They show up with the robotics on their robotics club on their resume, and you get to talking to them about it, and they open up. You start hearing about those experiences, John, you were mentioning. They start getting passionate about it, and you see that passion, and it makes you excited to hire them. But also you see that they can communicate something technical. So you think of it, oh, it's just a robotic club, but if you're passionate about it and you like it and you're good at it, that can go a long way. So little things like that, and then obviously you're going to meet a lot of people in those clubs that are also going to get jobs and be successful, and you've already kind of started your network.
Yeah, I would just add to that if you don't have a robotics club, that piece where you guys were talking about finding your own little pieces of projects, et cetera, go out, start anywhere, just do something and learn that gives you those same stories, et cetera. Any other comments on that one from anyone?
Yeah, I mean, not everybody has robotics, or I had it in college or high school, and we had to take it for STEM and stuff. But even, I look back at those DIY sites when some people out there have everything you need to do to build a project. That's a good, just to cross it off the list. If it's one of those things you really, at the end of this, you say, okay, I'm going to go do one of those projects on a weekend. That's on your resume. Nobody can take that away from you. So it's and reaching out. I mean, the blogs and the forums of all the major tech companies, they have very active members, and whether they're working for that company or just very enthusiastic about the products, make yourself an account and start talking to these people, or listen in and read it, because you'll learn a lot, and it'll keep you diverse as you go forward.
And you'll be surprised how many of them, like the guys on this panel, will actually answer back and will take an interest if you're passionate about something. So it's great.
Yep.
All right.
A little bit of an...
Go ahead, Melby.
Sorry. I was just going to say a little bit of an unpopular opinion. I'm not sure what the general demographic of the folks that are attending the call is, but if you are maybe a sophomore or junior in high school, in my opinion, I'd say zoom through your classes as much as you can, as quickly as you can. So definitely put an emphasis on experiences. So there are a lot of dual credit programs now. So take as many as you can in high school so that you have less classes in college. And then maybe focus, and this is based on my experience, maybe it's not the ideal way to go about it, but it worked for me, so I just wanted to share. So senior year, I took one class, and then I had a co-op that I worked at. It was at Northrop Grumman for a good 8 months. And so that experience really helped me, market myself for the positions that I got after. So I'd say focus maybe less on how many classes you take in college, but focus more on how many experiences you can market to other companies.
Yeah, I would agree with that. I remember I did my internship with General Electric, and I remember my father saying, "You do this for free just to have them on your resume."
And he's right.
Exactly. Right.
Yeah.
And I would say don't be afraid to try to get an internship like early in your collegiate career. Like I had an internship right after my freshman year. A lot of companies are interested in doing that, even if you don't have that much experience, because they can kind of groom you in their thought process and bring you up and provide training throughout your collegiate career. So don't be afraid and think you don't have experience to go out and look for internships.
And going off kind of what Sarah's saying, one of the challenges, and that's a question down here, was just what's a challenge. But Sarah, what you're saying, that was a challenge for me. When I was a freshman or sophomore in college, I'm looking for these internships and I'm asking people, I'm actually going out, I'm visiting with them, I'm going to the career fairs, I'm doing all these things. And, oh, you're a freshman, you're a sophomore, we'll see you junior, senior year. And that was a challenge that I had to overcome. And, what do you do, right? Who do you contact? And I actually found a little mom and pop machine shop that had a couple CNC lathes and just asked if I could come in and they would teach me how to program their CNC machine. I didn't know the first 8 weeks I would be sweeping, but that was part of it, right? And so once they saw that, the check's the same, I don't mind sweeping, that's part of it, because I knew eventually I was going to get to program that CNC machine. And I worked there for about a year as like my second semester of sophomore year or freshman year. And come to find out, they knew the HR manager at Parker Hannafin. And I end up getting, and so there's these connections that'll happen. And that's why you hear networking all the time, but you'll start witnessing it the more opportunities you take. But they're out there. You just have to kind of find them and find your own path, but they exist.
Yeah, and especially with the workforce challenges that the industry and the world is facing right now, they're looking for anybody that's willing to show that initiative and want to get involved. It's great. All right, let's see. I'm going to move to the next question. Were your career job positions planned, or did you grab opportunities presented to you based on your network of friends and coworkers? How planful were you? I can jump in on this one on my own, but let's see what you guys have to say.
So I'm a big planner. I plan out, 10 years ahead, and I can say for a fact, nothing goes according to plan. So
yep.
For me, I think you just kind of need to jump in and take what opportunities offer to you. A lot of times, and I know that, again, not a popular opinion, but in my experience, it has worked out. Do the job that no one else wants to do, because then you get that credibility so much quicker because there's no one else that wants to do it. And then you just get a lot of recognition from it. So I've always been in roles, even currently, I was asked to move to this new team. Didn't want to do it, not a huge fan of change, but take what opportunity comes to you and just make the best out of it. So, I spend 4 to 5 hours a day on my feet trying to figure out different issues. And it's not the most ideal situation for me, but I'm going to take it for what it is, learn as much as I can in this role, and then see how I can use that for my future opportunities.
Very good. Thanks, Melby. Did anybody set out or originally think, either in high school or even in college, that they'd be doing what they're doing now? Go ahead, Tayler.
Yeah, I might have been a little bit of a rare case. I kind of knew that from that first job, or head of maintenance, sweeping like Jarrod, and it was kind of something that I really wanted to get involved in. And so it was a direct path how to get there, and seeking out those co-ops accordingly, and then just learning up as much as you can, and just trying to be the jack of all trades. It stretches you thin, and it's not always the best to be what is that saying, good at all but not good at one thing. But you certainly, from not only an engineering standpoint, but if you start to see how businesses are run and you take an interest on that side of things, and project management, and improving some product line that you're not even involved in, or improving a company's marketing if they're an engineering firm locally and you think they could do better, that's just suggestions that are outside of your realm of interest. But next thing you know, you're getting looked at for, well, we really need you to focus on this new engineering team for a new product launch, or get involved accordingly. And the business keeps the engineers paid, so it's kind of a catch. If you can kind of diverse your interests, it's a good thing.
Yeah, so I would actually challenge your answer to say you actually answered no, even though you think you answered yes. Because I don't think that the job you're doing today you knew what it was, years ago, and but you knew you wanted to be in the industry. So, there's lots of options that way. Anybody else thoughts?
Yeah, so I had no idea this is where I would end up, right? So my undergraduate master's degree is in biomedical engineering, and I was actually designing polymeric scaffolds that you put stem cells on to do tissue engineering as my master's degree. And so that kind of morphed into doing consumer products, medical devices for a little while out of school. And then I kind of wanted to get more hands-on in the lab again. And then for personal reasons, Rochester, Minnesota was of interest. So I found a job at IBM, and I was kind of just doing like materials characterization that I was also doing like for biomedical applications previously, but now I'm doing it in electronics. And then I was like, oh, printed circuit board, that's kind of an interesting area, and I can gain more leadership experience in the company that way. So that's how I got there. But I never thought that I'd be working on printed circuit boards. And that wasn't anything that I, worked on in school, right? So it just goes back to most of your learning is in the industry, and school just teaches you how to think like an engineer and kind of solve problems, right? And then you take that and apply it to different fields. And so I kind of weaved through different industries and different roles.
Very good. Very good.
So, I knew I wanted to be an engineer, but I had no idea what type. And if a lot of my close friends in high school, if I told them what I was doing now, they'd be very nervous for Lockheed Martin probably. So I've come a long way. Maybe that says more about me than them. But no, had no idea what I would be doing, but I'm good at it. It comes naturally. You learn it, you learn the industry, and you get a little more comfortable and a little more confidence in it. Just have to keep some close friends around that keep you checked every once in a while. Those are the best friends to have. The ones, as soon as you start thinking, you're doing some good work and you're killing it, you need those people who are smarter than you to go, I forgot more than you've learned, right? Those are my closest friends. Those are the mentors I really look up to, because you need those folks in your corner. So always find someone smarter than you and learn from them, and then spin off and use what you've learned from them to go and better something else that maybe they didn't have the opportunity to improve.
Yeah. And you never know what opportunities are going to come your way. I had one day when I was working as an engineer for Chrysler, and for my job, I had to drive around a Viper at 110 miles an hour to test the audio system. And I wanted to call everybody I knew in high school and say, guess what I did for work today?
Yeah, that's awesome.
It was awesome. It was just kind of crazy. I had many of those experiences. That's just the first one that came to my mind. I want to switch to another one here that I think is good. Walk through just quickly, each of you, if you would, what's your day-to-day life look like? I think that's really important. Just help people understand kind of what's a typical day look like. Kind of take us from you arrive at the office, or you turn on your, your computer, depending on where it is, where you're at, to, you're done with the workday, et cetera. Help everybody understand that. Go ahead.
I can start. For my role currently, right, I do a lot of global interactions. So we have suppliers in Asia and Europe and North America. So I have to check the emails in the morning to see what the Asian suppliers, any issues that they may have had. So normally in the morning, it's a couple email responses, a few maybe meetings, and then I go into the lab and I'll be doing some qualification testing, setting up our test chambers and things like that, doing failure isolations, and then maybe some like cross-sectioning or scanning electron microscope analysis of the failures to try and address issues, right? And then maybe mixed in with some team meetings to kind of discuss and share problems and overcome different obstacles. But and then right now with COVID, it's kind of interesting because it's a little bit, right now I'm working from home, but some days I'll be in the office and some days I'll be half home, half office, depending on what I have to do.
Okay, next.
I'll jump in. So I start with the computer and emails. Everybody should definitely be familiar with working with emails, being responsive, and really taking some time to write out your thought to somebody's inquiry. It goes a long way, and then it shows that you actually care. And from there, it's on the manufacturing floor and understanding what has to be made to orders, and then at the same time, what's holding us up, and trying to figure out if it's a supply issue, going to find alternative parts, and while at the same time making sure you're getting the right parts in. It's a lot of juggling, but then a little bit after the initial set of the day, you start looking at the projects that are in process. So we do a lot of new products. We're custom electronics, so we have a lot of people coming to us with, hey, can you build this GPS tracker with liquid nitrogen monitoring system attached? And those are things that we take on, and at some point you have to stop and present, and then you have to gather your findings and making sure that if this is something you want to go down, as well as building prototypes and being familiar how to use like a CNC machine, and working on that to kind of create what you envision. I spend a lot of the day trying to do that, and there's a lot of scrap, but at the same time, there's a lot of learning curve on the job that really helps progress where I am at my career. So it's great to learn on the job. I think we all learn on the job with experience, and that's a lot of the day-to-day as an engineer in our office, at least, is trying to apply, because there is people here that know how to do it, but they're already doing something else. So you have to kind of, okay, I'll step up a little bit, and that helps you personally as well, I find. And then wrap the day and making sure that there's no fires, if there's any fires, and trying to make sure customers are happy. As the engineer, a lot of times salespeople bring in engineers to smooth things over, or to give a 2 cents to a new customer, or things like that. And that's where communication comes in, and being able to talk about your field of expertise.
Excellent. Melby? Oh, sorry, Jarrod, go ahead.
Oh, okay. I'd say usually I have something set up already first thing in the morning. It's usually a call, something I couldn't hit before the end of the day before. But for instance, kind of a day in the life would be, the first thing I'm doing is focusing on what didn't get done yesterday and knocking that out. And usually it's with the machine, or we're waiting on a response from a vendor or something. Then I usually have some type of standards committee once or twice a week, whether that be 001 or 610 or something from IPC that we're going to call in and kind of look through some of the comments. Then we have an innovation and technology lab that I oversee. So we have a lab where we have a lot of our ongoing evaluations and investigations for what we want to implement. Maybe it's an automated process, maybe it's laser marking, maybe it's a camera system, maybe it's a new ESD control system. It could be anything. So we work through those. Working on maybe a white paper here and there, a presentation. They finally got me Adobe access. I love making videos, and so a lot of our presentations, I'll go film whatever we're doing and actually put this in a video presentation, especially with all the kind of how the world is now. It's a lot easier to show it with a video than it is just a PowerPoint slide. Then we'll look at some, we probably have some team meeting where we want to get together and get everyone on the same page, update our projects, make sure we're all tracking to our deliverable dates. And then we have probably something else with another equipment, but there's one very important thing every day that we never miss, and that is lunch, and it is 11:30 to 12:30. So don't forget it. But we would go to lunch. I haven't been forced to give up my lunch yet. So it's very important, because that's kind of get out, talk to some folks, decompress a little bit, and then dive back into it. Another thing I oversee is our capital for our site. So any capital investments, new projects we want to invest in, or equipment we want to purchase. I think that's about it, and it kind of repeats, but every day it's always something different. It's always a different project. It's always a different initiative. And that's really good for me, because the repetitive, same thing every day stuff, I don't think I'd be successful at.
Excellent. Melby, how's your day?
So for me, I guess I should give some background on why I was requested to move into this role. So currently, because we're high volume, high complexity factory, there's a lot of emphasis from upper management on metrics. So they asked me to move over to kind of improve the metrics and make sure that, everything just looks much better than it is as it stands right now. So what I do on a regular basis is I come in, check emails. I think that's very typical for a lot of engineers. And then I usually go out to the floor and kind of keep an eye on, yesterday's defects, what we're running today, and then try to ensure that everything's running smoothly or can be run smoothly. So some days it could be, there's a missing part and I'm spending an hour or two finding it so that it doesn't stop our lines. Or it could just be, sometimes it's also the soft skills, right? So someone out in the factory floor is having a hard day, so they need someone to talk to. And usually I'll just listen and console. It could kind of vary across the board. But besides that, I come back to my desk around 10-ish to attend some meetings, and then prepare for the next day's work. And again, I have to go back out and facilitate some more things in the factory. But a general thing that I kind of keep in mind as I go throughout my day is, and this I think not only applies for work, but it applies just in general in life, I would say. For every year that I've been working, I try to tell myself that I need to uplift that many people. So I'm on my 5th year of work, and I try to uplift at least 5 people through the year that I'm in. So I think a part of my day-to-day is making sure that I'm reaching that goal and making sure that I'm creating harmony in the space that I'm occupying, I guess.
Cool. So the takeaway I would give for that question for everybody is the great thing about this industry is your day is not monotonous. You're going to be doing different things depending on the day. That takeaway. So I'm going to move to this next question, which is good. For those of you on the panel who've been involved in hiring at your company, I'm interested in your thoughts on this. It says, beyond the traditional college route, what options exist for non-college-based careers or opportunities? We're a career tech school earning industry credentials with the goal of joining the workforce after high school. So thoughts on that if you've been involved in hiring at all?
Yeah, so we have a couple technicians that just don't want to be, it's not really, they tell you they didn't want to be engineers, and maybe they secretly do, but maybe they really don't. They prefer the hands-on. They don't want to have to be sitting at their computers all day. They don't want to be answering emails. Some of you, they'll be kind of honest with you and say, I feel it gets political once I become an engineer and have to get into that realm. And I just want to be able to be hands-on on the factory floor, and I know machine's broken. I know how to fix it. One of our best, most senior technicians tells me the machines don't argue with them. They don't call in sick. They don't have an attitude. and it's so funny because he's right, but it's just, you never think about that. And, but he went, electrical technologies, no degree, but has a master's, I think it's a master's electrician, or he's a master's electrician, and went that route. He actually was installing, what are they called? I'm going blank. Internet routers and modems for years for Suddenlink or Consolidated, or pick a company that they were installing those at residential houses. Then he went commercial, and then he just said, I want to do something a little different, and jumped in with Lockheed. And he's one of the best guys we have. And not only is he really good, but now he's training a lot of other technicians as we're growing and we're expanding. And he's kind of like a silent worker. Some days you never know what he's working on, but when he's not there, everything tends to break. Right. And so we need him. But yeah, that's like the backbone of our factory, our technicians. I would actually say they're more important. Our engineers can innovate and automate things, but if we can't keep the things we're building with running, we run out of money very quickly. So yeah, I don't know if that answers the question, but those are my thoughts on it.
Anybody else have any thoughts? I have one if you don't. This is from my senior lecture before I graduated as an electrical engineer. They had all the electrical engineering students together, and one of the final, they said, "Hey, by the way, you see that building just south of us? That's the electrical engineering technology building. If you guys are the doctors, they're the nurses. They actually know how to do the stuff that you guys are doing the math for. And so you can't live without these guys. You need to actually work with them, because without them, yeah, it's all theory, and that's not nearly as exciting. So there are positions available. There's there's engineering positions that the industry's hiring for. There's technician positions the industry's hiring. Even if you don't even have certifications, there's operator positions that you can, entry-level operator positions you could come into very quickly, literally with just a couple days of training, and start getting your hands dirty, so to speak, in the industry.
But, and John, not to just go back to it, but and this isn't just a Lockheed Martin thing. A lot of companies, if you come in as an operator, they have tuition reimbursement and payment options to help you go and get your degree. Some of our best engineers, I would say almost all of our top producing engineers that constantly have their name on the wall or promoting super fast, they started as operators.
Yep.
And
right.
they knew how to build it. And it's crazy how fast you see those individuals promote because they know the hardware.
And it's also nice to promote and get those degrees without any debt.
Yes, details.
Minor
Yes.
details. That was my great plan with my MBA. I was like, oh, hey, I can get the company to pay for that? That's awesome. I'll have them do that, you know? And anyway. This next one, John Mitchell, how long did it take you to get where you are? Since I've been in the industry, let's see, I'm 197 years old right now. So it's been a little while. I don't know. It took me about 3 minutes to walk downstairs to the basement, if that's what you meant, because my wife's relegated my office to the basement here while I'm working from home. Let's see. I graduated as an electrical engineer. I'm 55. There's no mystery about that. I still think I'm, 25 and still learning things. So it takes you as long as you want to be passionate about something. I've changed careers a number of times. Started off doing electrical engineering for General Electric, moved to Alpine, and we brought navigation systems to this country and refined that. I went to Bose. I did amazing things there in the automotive space, which was just so much fun to be part of that. Then I moved into the nonprofit world and did a charity for a while, ran that. So it's a lot of different experiences. And my role right now with IPC is actually the juxtaposition of all of that, from engineering to business to education. I got my doctorate in education, got my master's in business, and I have my undergraduate in electrical engineering. So being diverse and trying to do a lot of things allowed me to find different opportunities. But back to that question that was asked a little bit ago, did I know where I was going? I didn't even know what a trade association was, when I was in school. I remember as an engineer thinking, those guys who got business degrees, they're the devil. They just care about money. That's bad, disturbing the pure engineering solutions. And, at later times I thought, oh, working with governments, oh, these guys get in the way. Oh, what a problem that is. And now what do? I'm out there working with, I've met literally the president of the United States got called out on national TV for this stuff. So it's just, the world changes around you. So just roll with it. Anyway, so that's enough about that. Is there anywhere I can take courses to learn electronic design for cheap? Because I really just want that to be my future path. So I think Jarrod's comment about companies paying for education is a really good one on that front. IPC does have a lot of different courses, which we can get to you as well. Some of those are rather inexpensive. There's also a lot of free stuff out there that you can start with. And then there's people that will share those things. But any other thoughts on the design stuff, people, that you'd like to add to that?
Go to Apex.
Go to Apex.
Go to Apex. That's the biggest bang for your buck right there. Go to Apex. That's everything you could want.
I didn't even pay him to say that. That was great.
Yeah. Yeah, I'm waiting for my shirt.
Go ahead.
Well,
yeah, Jarrod, of course, go to Apex. That's but I think the real simple answer is, YouTube. And I mean, I still use it today for looking at, a new potential. We were doing liquid nitrogen probe and level monitoring. And I found just popping around that somebody was using coils, like Tesla coils, and the resistance of the wire changes nearly by 40% when it's fully submerged or half submerged in liquid nitrogen. And then we were kind of like, that could solve it. That might be a viable prototyping solution. And I think that's where a lot of hobbyists are shining right now. And hobbyists are there's subject matter expert in their project, and you can learn a lot. So don't be shy, because the resources are out there for sure.
All right. Charlene, we end at the half hour, right? So we've got about 17 minutes. And so I'm not gonna get to all of these questions. It's great that all these questions are coming in, but let me just try to pick and choose. I like this one. What failures or obstacles have you experienced while in the field, and how have they impacted you today? I always like to hear about failure stories, because that's how we learn. Anyone? Jarrod, go ahead.
Yeah. So I was, I'll give you an example. I gotta think of the best way to say it, but we have an assembly. We're a build to print shop, right? So whatever the print says, that's how we're building it. And we're removing a component and putting another component on there. And it's a soldered on, component. And so we're going to rework it by using a hot air method, and we're going to heat the part up, reflow the solder joints, and remove the part and replace it. Well, the part we're moving, there's no issue with, but the rework procedures were approved. Everyone's good to go. We go ahead and get the approval to do 40 of these cards. We do all 40 of them one weekend and come back, and we're high-fiving. We're going to meet rates. We did it fast. Everything looks good. And one of our, I believe he was an electrical engineer, was looking over the rework procedures and said, "Hey, what about this component?" And it was a different component than what we removed on the other side of the card. And we said, "Well, we didn't touch that one. It's good." And he goes, "Well, it has a temperature rating of 120 degrees and solder reflows at 183 C. And so we have an issue, because we know for sure that part got too hot or whatever, we knew it got overheated." So we ended up scrapping all 40 of these cards that I dispositioned. Now, it's a very expensive lesson to learn. These are not cheap cards. You scrap one of them, it's a bad day. You scrap two of them, you want the day off. You scrap 40 of them, you don't know if you're gonna have a job, right? So luckily, trust but verify. This was a thing that was not on the drawing. There was no requirement that we were told to meet. There was, there's no way that I, myself, or anybody could have known about it. But these are the things you have to look out for: is trust, but also don't be afraid to ask other questions. Don't be afraid to take some time. Now, did we do our due diligence? Yes. Would it have happened all over again? Yes. But did we learn, hey, if this is a requirement, it needs to be notated and on the drawing so this doesn't happen again? When we actually look back at it, this exact same thing happened 3 years before I was even hired. And again, it was missed and not put on the requirements. So these are things you learn. And it's not just with, where I work. I've seen this at Parker Hannifin with the same thing, right? We're building blowout preventers or in rubber manufacturing, and we kept getting shards in the rubber. And what do? Well, supervisor comes out with a black Sharpie. Nope, that's not an appropriate response, right? So you just learn things, but these are mistakes we all make, and you learn from them and you get better, and you definitely don't duplicate them. That's the biggest thing to do. If you mess up, that's fine. Own it, grow from it, and don't duplicate it.
Awesome. Any other experiences you want to share?
I think for me, it's been more of, I guess a bigger obstacle for me was once I started work, I think I came in a little too naive. So for me, over time, I've realized that despite being a minority in a lot of ways, talking about gender, ethnicity, and age, I think I've come to realize that my opinion matters just as much, and having a voice is really important, and understanding that we're all from different walks of life in general, and everyone comes in with experience that other people don't have. So it's important to understand that imposter syndrome is very real, but it's something that you can overcome, and that I think is an obstacle that a lot of young engineers feel, but know that you can get past it.
All right. I'm gonna answer one other question that's on here. If I'm incorrect, Charlene, you need to correct me. But first, let me thank the panelists. I know we're doing some raffles here at the last bit of the presentation. We want to make sure we have a chance to give all of you the opportunity to win some goodies. But the question I wanted to answer, and Charlene, correct me if I'm wrong, is will we be able to get a link to this recording so that we can share with other classes? And I believe the answer is 100% yes. This is being recorded and we'll make it available to you. So reach out to Charlene, and the contact information will be on the last slide. But with that, Sarah, Tayler, Melby, Jarrod, thank you very much. Great, super awesome panel. Thank you guys for being so candid and open with your opinions, and being willing to take a little time with not only with me and IPC, but with all of the students and people online.
Yeah, thank you.
Yeah, thanks. And feel free to reach out to anybody out there. Certainly love to hear cool projects, or if you guys
You can probably find all these guys on LinkedIn. Just reach out to them.
Yep, absolutely.
All right. Charlene, it's yours.
Actually head over to Aaron.
Sorry, it's actually Aaron's. Yeah.
Fine, John. Thank you so much to Sarah and Melby, Jarrod, and Tayler. It's wonderful seeing you all. I know we've had some chats at previous events.
Hey, Charlene,
yes.
your microphone's messing up on it, but it's really hard to understand you. Go ahead, Aaron.
Hi, everybody. I'm Aaron, Program Manager for IPC's Education Foundation, and I get to do one fun thing before we leave. So we, as you may have seen in the registration, are raffling off Bose headphones. Bose build headphones. They are sort of these DIY, pretty cool headphones. They're Bluetooth. They're a little bit custom. There we go. Those are it. So what we'll do, I actually already randomly drew names from all the attendees and the registration list. There's 25 names, so we'll be sending 25 of you individuals the headphones. If you're with a school or a chapter, or you're a teacher, you're welcome to do what you would like with the headphones. Raffle them off to your class if that attended. If you're an individual winner, awesome, congrats, keep them, Merry Christmas, give them to somebody in your family, whatever you would like. So rather than read all of the names, I'm just gonna drop all 25 names in the chat. Congratulations. There you go. So you're welcome. Search for your name. Hopefully it's in there. If it's not, sorry, but thank you for attending. And there we go. We have some people happy to win. And I think that I'm pretty much rounding this out. I just want to say thanks to Bose for the donations. They donated that to our foundation. So be thankful and give them a little extra love. Thanks to all of our attendees. Thanks to our speakers, Melby, General Dynamics, Jarrod with Lockheed Martin, Tayler Swanson, Digital Instruments, Sarah with IBM. Obviously, John, our generous host, always enjoys connecting with our students and our network. My team, Charlene, other folks at the IPC Education Foundation, and everybody for your participation. So I think we may send off with Charlene. Her microphone might, hopefully it's working. Maybe. Okay. I'll let John do
take us home, Aaron, or I can say,
there.
Basically, you can see the last slide. We'll have the recording available very soon, and we hope you'll be able to share that with everyone. We'll be mailing the headphones out to each of the locations. I believe Aaron has, since he has your name, has your contact information as well. So he'll be sending that. If you have any questions about that or not sure, feel free to email Aaron. His email's right there at aaronburney@ipc.org. Also, get involved. I think this is the key message of all of this. So whether it's the IPC Education Foundation or even getting involved in an IPC standards committee or something along those lines, or take an IPC training, we're happy to help you along your journey. If you have any questions, feel free to reach out. Thank you all for today.